Hello, I am outside, so if you hear wind on the microphone, could be me just breathing into it. I have a bad habit of that. But also, there's the light breeze. Actually, it looks like there may be a thunderstorm moving in, so I may have to cut this short. But I only intend to talk about the first part of this presentation and break it into pieces anyway. So let me get it going here full screen. And this, I'm going to tell you all, is my favorite part of this class. Okay, I like talking about chemical bonds and introducing you to the parts of an atom and all that sort of thing. But I, for some reason, just really enjoy talking about and drawing out organic molecules. I don't know why. I get so excited about these structures, but I do. So bear with me. Okay, first of all, we have inorganic molecules. We've been talking about those a bit. Our salts, things like that. Those are inorganics. Organic molecules always contain carbon and hydrogen. Okay, so that's where we're going to start now. Is they contain carbon and hydrogen. You say, well, wait a minute, we have carbon dioxide. We talked about that. That's inorganic. Why is that inorganic? It contains carbon. Carbon, but no hydrogen. It's got to have both. Okay. Water, H2O, contains hydrogen, but no carbon. Okay, so those are inorganic molecules. Organic has to have both carbon and hydrogen, usually in some type of ratio, depending on what type of molecule, of organic molecule it is. So we have the first type of organic molecule we're going to talk about is the hydrocarbon, and it has only hydrogen and carbon. I think that's thunder. I'm outside with a computer. I'm under an overhang. Well, we'll be okay for a bit, I think. Okay, so carbon, hydrogen. Other types, as we get into those, are going to have things in addition to hydrogen and carbon, but just hydrogen and carbon. So here's an extreme example right here. What is this? 1, 2, I'm counting carbons. Count them with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay, this is called no name. How does she know that? Hydrocarbons with single covalent bonds between the carbons are called alkanes, and this is our first type of hydrocarbon we're talking about. Notice that all the carbons have a single, let me get my little cursor down here if I can find it so that you can see what I'm pointing at. Why can I not find my cursor? I've lost my cursor. Maybe it's just because I'm outside. My screen is not as dark as I think it should be. Okay, never mind. You'll just have to look. So there it is. Okay, so I'm on a white screen. That's part of my problem. Okay, so notice between these carbons, single bond, single bond, single bond. That dash is a bond. Okay, we've already had that. We've talked about that with our other types of structures we've drawn out. Okay, one dash is a single bond. If there had been two there, it looked like an equal sign. That would be an indication of a double bond. Okay, so review of that. All right, so these are nothing but single bonds. And they're named by the prefix for their number of the longest chain carbons and the ane suffix from alkane, ane. Okay, so isomers, that's something that has the same chemical formula but a different structure. And so let's do some naming practice before we go to alkenes. And I may just call us good at alkanes because that's usually what I would do. And I don't know if I've got any practice sheets for you on this. I'll have to go look and see if I can find some. I know I don't have any digital ones. They were all photocopy handouts, so I may have to see what I can come up with and put that on there. Okay. Excuse me. There we go. I'm going to see if I can insert in here a blank slide. Blank, blank. There we go. And did that go in where I wanted it to? It didn't, did it? Oh, let's move it up. There we go. Okay, so now I have a blank slide. And I'm going to go back to full screen, I think. I'm having a hard time seeing my cursor out here in the daylight. Okay. And then I'm going to come up here and see if I can get my little drawing tool. And let me get a color. Let's do white since I'm on black. All right, so in your book, oh wow, do I have my book out here? What page? Let's see. I believe these are in page chapter, looking at chapter 10 or something like that. Yeah. Okay, so it's chapter 10. You're going to want to go to a table in chapter 10 on page 333, where it gives you these straight chain alkanes and it gives you the names. And the abbreviations are kind of there based on numbers. There used to be a different table that broke it down into just what the prefix was. In the other book, you know, the one I started off teaching out of before I got the right book, the old version. Let's see. I don't see that table in this one. Okay, so we'll just go with that. But notice that if you look at that and you're looking at it with me, you can see that you've got italicized beginnings there. So meth is for 1 carbon, eth is for 2, prop 3, but 4, pent 5, hex 6, hept 7, oct 8, non 9, and dec 10. And that's where I got nonane for that first one. Okay, 9 carbons, all single bonds between the carbons. It's an alkane, 9 carbons, known ane, known nane. All right, so let's look at that a little bit right here with some practice. So I have 1 carbon. Oh, that's kind of strange. Okay. Okay, I don't know, can you see that? Is that, I hope you can. Okay, 1 carbon, and I'm gonna draw out here like this. I may change to brighter color. All right, and we can leave it like that. Scientists do, chemists do this. This is shorthand. We don't bother drawing all these H's around it because if we don't put anything there, then we know by default, H, hydrogen, is the default, okay? If it were anything other than hydrogen, you have to draw it in there. Otherwise, you can leave it. Okay, so 1 carbon, this is methane, okay? All right, we erase that. Actually, I think I can erase all. I'm just gonna erase all. Where did I see that? Clear all drawings. Here we go. Okay, and I can start again. So here we go. Oh, let's do a different color. Do something bright. It's not bright. Looks bright. Bold. Maybe a little bit better. Okay. All right. No, I don't know. Anyway, I've got 2 carbons. So 2, 1, 2. Again, I'm not going to draw the hydrogens this time around. Ethane, 2, F. Okay, I put 3 on there. Methane. I put 4 on there. Butane. 5. Pentane. You get it, right? Okay, so you can practice that, play with that. I always have a little trouble getting it to let me go back after I've used my little tool here. Come on, go to the next. Okay, well, maybe I'll just stop there. There we go. Stop there and go on. I think I can talk about alkenes on this presentation here. I'm going too long because all we do with alkenes is we add a double bond in. Now, I am going to stop and say something here. If you go back to a previous the previous section that I didn't make a presentation over. I just put notes up there for you to look at because it's mostly review. I think there may be a term or two there, though, that isn't exactly a review, and I do want to go over it. Something we call saturated and unsaturated hydrocarbons also applies to lipids, fats, okay, because they are hydrocarbons. Okay, well, they're not really hydrocarbons, but they're organic molecules. They have hydrogen and oxygen. Hydrogen and carbon and oxygen on them. Okay. All right. So that's where we're going. We're getting into those organic molecules that are constituents of cell structures. Okay. We're starting with these though because this is the basic and we build on it. So unsaturated. Well, let me start with saturated. What we just looked at was a saturated hydrocarbon. Okay. I cannot squeeze any more hydrogens onto this structure anywhere. Every carbon can take 4 bonds, and all 4 bonds are filled. Okay. Now with alkenes, though, alkenes have a double bond somewhere, and so you name them the same way. You count the number of carbons. Okay, and the longest chain. Oh, what did that mean? Okay, well, let's go back here. Hey, that's oh, it wasn't as thick. I did a shorter line. Okay, I'm going along here with this, and then I do something like this, and then I come over here with this and this. Oh, I can do this. How would we name that thing? Well, it gets more complicated. Okay, but then I need to talk to you about that. But first of all, I got to figure out where's the longest chain. Is it just always what's straight? No, you got to count. You got to go around the thing. I mean, I could even do this out here. Okay. All right. This looks weird. Probably wouldn't really be drawn this way, but it could. You start counting. Doesn't matter what end you start counting. We can start here. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6. No. Okay. Well, here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So that, this right here, follow the red line, is our longest chain. We could take that and straighten it out. All right, and if we straightened it out, then we would have with the oxygens coming out. Now, what is that? Name it. 8 carbons. Name it. I can't draw. I can't write. Okay, I don't have an iPad or anything. I'm doing this with my touchpad and my finger. I'm finger painting. Okay, all right, but this isn't the same one. Okay, look, I've got to come over here. I got to go 1, 2, 3. Okay, I've got a carbon coming off of 3 here. I've got a carbon coming off of 1, 2, 3, 4. This one, because this is our straight chain. This got straightened all out here. So this is now right there. Okay. All right. So what is this called? Now, what you do is if I'd stuck these down at this end, if I put them on these 2 carbons, we would start counting from this end because you start counting from the end where the attachments are the closest. Okay. So it doesn't matter what end you start counting from exactly, except that you do have to go for the attachment that's closest. Okay. So what kind of group is this? I'm going to make it more interesting. I'm going to go ahead and say, we had this here. That still makes this the longest chain though. 1, 2, 3, 4, 5, 6. Yeah. Okay. There we are. Okay, still octane. Didn't change anything. I just changed the attachment here. Okay. These are groups. Okay. So what I have here is this is a 1 carbon group. So what's the prefix for 1 carbon group? Look on 333. What's our number 1? A while ago we had this. What was it called? It's called methane. Okay. So this is what's called a methyl group. Methyl group. Okay. All right, and we're going to write that, and we're going to put the number of the carbon it's attached to in the chain, and that's going to be part of our name, okay, for our thing here. So this is for our alkane. We're still on alkanes. Okay, 1, 2, 3. So this is 3 methyl, comma, 1, 2, 3, 4. Oh my goodness, what's this group? That's a 2 carbon. So what's 2 carbon? 2 carbon is eth, right? Okay, all right. Some people, I think, put a dash in between there. I don't know. Okay. And I'm having trouble writing the further along I get there. Fingers are getting tired. Okay. 3-methyl-4-ethyl octane. Okay. That is a separate word there. Like I said, you either put a space or a dash. Okay. It's not, doesn't run together like that. Looks like it's running together there, typically speaking. It's my eraser. What happened to it? There we go. Okay. Yeah. So that's how we name these things. It's, you figure you find your longest straight chain, or if you straighten it out, what would be the longest chain of carbons? Count your carbons. Put your groups on the number of the carbons starting at the end, the closest to the first group. Okay, and then number those carbons and tell what group is attached to that carbon. You go in order of on this one, you go in order of the carbon they're attached to. I'm pretty sure there's a point, I have to look that up. There's a point where you do alphabetical, but that's when they're attached to the same carbon. Okay. What does she mean by that? Okay. So if this ethyl group had been attached to this, and it would have been a 3, it would have been 3-ethyl, 3-methyl. Excuse me. You list the, if they're on the same carbon, you list them alphabetical first. Okay, in alphabetical order. So that's just one of those little weird things. So that's alkanes. Alkenes, as I started to get into, just has a double bond in there somewhere. So that would be, using this drawing here, that would be something like this. Don't think I want all this mess here right now. Okay, we'll do something different. Well, I probably won't even really go into that as much. Now you've seen that with the alkane. Okay, so this would be an alkene because it's got a double bond. Just one double bond is all it takes. It can have multiple double bonds, but if it's got one, it's an alkene. Okay, so what would this be? Count your carbons. 1, 2, 3. Look at your table, 333. So, well, it's going to be prop. Would be propane, but this is an alkene, so it takes the ene ending. So this is going to be propene. Now, when we get into bigger, and if it were just this ethene, we don't have to designate numbers as to, we usually use numbers to tell us where in this structure the double bond occurs. But in ethene, there's only one place it can go. And in propene, there is two. And you say, well, no, it could have been over here. But remember, we start numbering from the end of the group. Well, we also start numbering from the end closest to where the double bond occurs. So this would be one propene. But if I erase this and stick it over here, it'd be one propene. So it's propene. Okay. So here we go though with one that if we had our 4-carbon structure, all right, and I put my double bond here, that's 1 butene, 4 but, remember, okay, 4 butene. But then if I put my second bond here, that will be 2 butene. Okay. They say, well, what about if it were here? Well, that's the same as there. Just turn it around. So what you have to understand about these structures is that they're drawn out here in flat land. They look all flat and everything, and one-dimensional, one-directional too. They're not. If I were to, this is real easy to explain when I'm standing up in front of class, because what I'll do is I'll hold my hand up in front of myself off to the side a little bit, and I'll say, okay, you see my hand? And the thumb is pointing to my right. I've got my left hand up. Thumb is pointing to my right. But then I turn around and put my back to you, and I say, now which way is the thumb pointing? It's to my left. But has my hand changed? Nope. Hand's still the same. It's my left hand. But if I couldn't see it front and back, and all I could see was the thumb coming off of 4 fingers, I turn around and I think it's the other hand. Okay. If I'm looking at it from the opposite side. And that's what we're doing here. Basically, if you draw the carbon double bond here on this end, instead of that end, it's just looking at it from the other side. Okay, because we'd be numbering from the left-hand side instead of the right-hand side, but it's the same thing. It's the same. So these are 3-dimensional structures, and you've got to realize that you can draw it up in the air and then walk all around it. Okay, and this perspective of whether that is between carbon 1 and 2 or carbon 3 and 4 is just whether you're looking at it from one side or the other. Okay, so that's why on the ends there, you start numbering from the end closest to the bond, the double bond. So this would be our 1 carbon now, instead of this being our 1 carbon. Here it doesn't matter because it's in the middle. Okay. Okay, so hopefully that kind of explains that. We can get those same types of structures off of things. Let's go ahead and draw. Oh, let's don't. Butene. You can do that. Either one of these would be the longest, right? So it's going to be 2 butene. This would be a methyl group, so it would be 2-methyl 2-butene. Okay. Ick. Yeah. I'm gonna go ahead and erase that off of there. So these have carbon chains off of them. It's just as long as you don't get more 4 bonds off the same carbon, you're good. That just means that this carbon, if that drawn there, that carbon has no hydrogen attached to it. It's just 2 bonds to this carbon, a bond to that carbon, then a bond to the carbon that I stuck up there on you for a little bit. Hexene. 2-hexene. That's where we start our numbering from. 1, 2, 3, 4, 5. Okay, and so when we were playing these numbering games, these drawing games, it's like, what's possible? And actually, it's like, do these things actually exist? Okay, and for these numbering naming exercises, in some cases, well, I think maybe they could exist, maybe they're not very common. Maybe they don't exist at all. Okay, but if you were to have this structure, any of these structures, this is how they be named, and this is what they draw. So in the handout, I'm going to have for you to practice naming and drawing these things. I will actually have you go from the name too. If I give you a name, can you draw? Okay, can you draw it? Can you tell me where that? And you just go off of the name. It tells you where the double bond is. It tells you what unit to stick the group on. Okay, it's all very patterned. And once you learn the pattern, it's really easy to apply it. Okay, across the board. In your book on chapter 10, there are all of the rules written out for you. Okay, if you wanted to use that for reference, I highly recommend that because it's it's great to see them all laid out there in print and all of that. But my point here was not read that to you or go really over that with you, but show you. Okay, here's how it's done, and then you can go there and look at the printed rules um, for clarification or reference. Okay, and I think I will stop there and come back and we'll do alkanes. No, I'm sorry, alkynes, and then we'll talk about some cyclohydrocarbons as well. Okay.